Hi guys, today we're going to talk about how to solve problems that are on your Newton's second law problem assignment. In fact, we're going to go through the three examples at the top of the page just to make sure you know exactly how to do it. So the first thing we'll do is quickly review the formulas. You know, of course, the most famous way to write it is F equals ma. Force equals mass times acceleration. So if you're asked to find force, this is the quickest way to do it. If you're asked to find mass, of course, you rearrange the equation and find m equals F divided by A. And if you're asked to find acceleration, you would use A equals F divided by m. Now, a lot of people like to use the little triangle here at right to just remember how to do these problems. If that helps you, great. So let's look at the first example problem. What net force is required to accelerate a car at a rate of 2 meters per second squared if the car has a mass of 3,000 kilograms? What do we do first? The first thing we do is figure out what is it asking for. In this case, what net force is required? So the first thing we do is write the formula. And that would be F equals ma. We choose to write it this way because the question asks, what's the force? So it's got to be F equals. Next, let's look at filling in. Okay, we know that mass in the problem is 3,000 kilograms. So we have mass is 3,000 kilograms. That leaves us one more thing to fill in. Acceleration. Acceleration is given in the problem as 2 meters per second squared. So we write that in. Now all we have to do is multiply to find the answer. 3,000 times 2 is 6,000. And of course, kilograms times meters per second squared is a Newton. So our answer is 6,000 newtons. Now let's look at the second question. What's the mass of a falling rock if net force of 147 newtons produces an acceleration of 9.8 meters per second squared? So this time we're trying to find mass. This means we have to write the formula m equals F over A because we're finding mass. So we got to start with that m. Now let's look at filling it in. First, the force. The net force in the problem is 147 newtons. So you should see how we get it out of the problem and where it goes in the equation. And then finally, acceleration. Given to us is 9.8 meters per second squared. We fill that in. Now, once we fill it in, all we've got to do is divide to get the answer. And 147 divided by 9.8 is 15, or to two significant digits, it rounds to 15. And a Newton divided by a meter per second squared, well, that gives us kilograms. Mass is measured in kilograms. So the answer to this problem is 15 kilograms. Let's look at the third example. What's the acceleration of a softball if it has a mass of half a kilogram and it hits the catcher's glove with a force of 25 newtons? Now, obviously, we're actually going to be slowing down. We know this is going to be a deceleration because we're bringing the ball to a stop. But we're just working it with straight numbers without worrying about symbols right now. So when we realize that we are asked to calculate acceleration, we write the formula A equals F over m. To solve for acceleration, you got to start with A. Now, the force given in the problem is 25 newtons. The mass given in the problem is 0.5 kilograms. Again, it's a divide. So when we do 25 divided by 0.5, that's 50. And a Newton divided by a kilogram gives us meters per second squared. So the correct answer is 50 meters per second squared. All right, I hope looking at these sample problems has helped you understand what we expect, how we expect you to show your work. Remember, it's always 3 steps. Write the formula, fill in the numbers with the correct units, and write the answer with the correct units. Have a great day.